What is the difference between electromotive force, EMF, and voltage? And what is the difference between electromotive force and potential difference? Before starting the lecture, click on the subscribe button and get access to our 100 of unique and simple lectures for free. Firstly, let me teach you the concept of driving force. Well, consider a car standing on the top of a mountain. Here, this car possesses high potential energy because of its vertical position above the ground and gravitational field. We know that this car moves from the top of the mountain towards ground by itself. When car reaches to the ground, its potential energy becomes zero. So this is low potential energy region, and this is high potential energy region. From this example, we learn that object moves from high potential region to low potential region by itself. Secondly, when this car moves from high potential region to low potential region, its potential energy is converted to kinetic energy due to motion. Now let's consider another car on the ground. We know that its potential energy at the ground is low. I am interested in moving this car from the ground to the top of mountain. Does this car moves from the ground to the top by itself? The answer is no. We need some sort of force that should push this car towards the top of mountain. We know that engine provides that force to move the car to the top of mountain. This engine force is called driving force. Once the car reaches to the top of a mountain, it will again accelerate towards the ground by itself. So thirdly, we also learn that we need driving force to move an object from low potential region to high potential region. Now listen carefully. From this example, we learn three universal facts. Firstly, objects move from high potential region to low potential region by itself. Secondly, when object falls down from high potential region to low potential region, they possesses kinetic energy due to motion. Thirdly, we need driving force like engine force to move an object from low potential region to high potential region. Now let's consider 2 points P and Q. Let's consider 5 charges at point P and 2 charges at point Q. Let point P is a high potential energy region and point Q is a low potential energy region and electric field. Let the potential energy of the charges at point P is 10 joules. And the potential energy of the charges at point Q is 3 joules. As we learned in the previous slide that any object moves from high potential region to low potential region by itself. Similarly, charges also move from high potential region to low potential region by themselves. We know that the potential energy of charges at point P is 10 joules. And the potential energy of charges at point Q is 3 joules. The potential difference between point P and point Q is 7 joule. Thus we define potential difference as the energy difference between 2 points and electric field is called potential difference or electric potential difference. Let me repeat it. The energy difference between 2 points and electric field is called potential difference or electric potential difference. Secondly, we also learned in the previous slide that when an object falls down from high potential to low potential, they possesses kinetic energy. Similarly, when charges fall down from high potential to low potential, they also possesses kinetic energy. Now, how much kinetic energy is possessed by these charges when they flow from high potential to low potential? Well, we know that these charges possesses 7 joule kinetic energy when they move from high potential to low potential. We also know that these charges move from point P to point Q due to potential difference, and they possess 7 joule kinetic energy. We call this 7 joule kinetic energy of charges voltage. So we define voltage as energy possessed by charges due to potential difference is called voltage. Let me repeat it. Energy possessed by charges due to potential difference is called voltage. Remember that we can utilize the 7 joule voltage of charges. For example, we can convert the 7 joule voltage to light energy, sound energy, heat energy, etc. Thirdly, we learned in the previous slide that we need some driving force to move an object from low potential region to high potential region. Similarly, we need some driving force to move charges from low potential region to high potential region. Here, we use a battery to provide the necessary driving force to move the charges from low potential region to high potential region. Once the charges reach to high potential region, they will fall down to low potential region. The battery, being driving force, will again move the charges from low potential region to high potential region, and charges will again fall down to low potential region. Thus, battery keeps the constant flow of charges in the circuit. This battery is called electromotive force or just EMF. So we define EMF or electromotive force as the driving force of a device that keeps the constant flow of charges across the circuit. Let me repeat it. The driving force of a device that keeps the constant flow of charges across the circuit is called electromotive force or EMF. Remember that EMF or electromotive force is a force that motivates charges to go from poor conditions towards better conditions. So to summarize my lecture, we learned that energy difference between 2 points in electric field is called potential difference. Secondly, we learned that energy possessed by charges due to potential difference between 2 points is called voltage. Thirdly, we learned that the driving force of a device that keeps the constant flow of charges across the circuit is called electromotive force. This was all about electromotive force, voltage, and potential difference.